Hello and welcome everyone. I'll just check the date and we're in October, so to alt.net October. So in the studio we have George, who's very kindly volunteered to give us an exciting talk on graphs and AI and bring it all together. And we have Francis, who, you moving there, Francis? Yes, Francis from South Korea, though you might have and George at the last drinks. It's usually in Sydney. All right, so say hello in the comments if you're there. Hey, Andrew's there, that's good. So we'll just make sure we've got some people watching before we get too far into things. But it's a good sign. So I'll give it a minute or two. Any more comments? Roll up, roll up. This, by the way, is not my real background behind me. I just didn't tidy up my office, so I just put on the background. Let's see.
Maybe we should have all synced up our backgrounds. It's the same one.
You'll go for it. It's a choice of only one background, so you all have the same ones. If you look behind Francis, you can see what Korea looks like. It's very foggy and polluted in Korea, so you can't see very much. No, is it just blurred? I think.
Oh, okay.
Yeah, I just blurred it just to stop being a distraction.
Oh, fair enough. All right, so we have an audience, I think. So maybe we should. Well, we have, as usual, the JetBrains licenses to give away. So stay to the end, and I'll keep track of a couple of questions on George's talk and ask you. And if you get the right answers, then you'll get the free 1 year for JetBrains. And if you do get the free 1 year for JetBrains, we encourage you to give a talk, though it's not compulsory. But yes, it's great if you can. In fact, George volunteered, and we've got Stephen for our next talk, actually, and he also got a license and volunteered too. So there's a tradition now that when you win the license, you need to volunteer. All right. So
yeah, I've got something to add actually. So just with JetBrains licenses, if you do win something, if you do win it, don't spend it on a JetRider, because I think JetRiders now they're giving it away for free. So yeah, go spend it on another ID. I don't think you need to spend it on a JetRider ID, rider ID, I should say. Yeah, just wanted to add that.
You can spend it on ReSharper or IntelliJ or whatever else. All right. Well, maybe we should get into things. So, you up for a bit of an intro for George, Francis?
Yeah. So I've known George for quite a few years now. I met George in a co-working workspace, and he saw my setup with multiple monitors and came up to me and said hello, and we just hit it off, and we've been friends ever since. So I'm actually stoked and very excited that George has not only taken the time, but I know giving talks doesn't come naturally to most people, and so I'm sure George is excited, but also a little bit nervous as well. But I'm actually also very happy that he's just stepped up and stepped up to give us a talk tonight. So I can't wait to see what he's got to say and what he's going to present today. So,
and he's been preparing for it too. So. Doing some serious preparation, not just off the cuff. So it should be really good.
Oh my goodness, guys! Yeah, you're now setting me up for some code crash. Yeah. All right, shall I get started, or?
All right, I'll pop up your screen. Let's put us to here we go. And I'll put George on the top here because he's the important one. And sorry, Francis, you're at the bottom. Put me at the bottom. There you go. Francis in the middle. So take it away, George.
Oh, okay, great. Thanks, James, Francis, for the invite. Yeah. I felt, in a way, just sort of like coming into the AltNet group in the last I think, I'm not a regular, but intermittently I do drop by. So I thought, why not? When James and Francis, you guys asked me to, whether I'd like to give a talk, I thought, oh, I'm someone who probably prefers a more one-on-one interaction, but I think, with with sort of like the topic that I'm planning to go through today, it's always good to have, to sort of like package all these little bits and pieces together, and then sort of like, and hopefully some, folks could get some ideas of how to take knowledge graphs and where LLM fits in, into the mix, and get some ideas about how they might, want to think about using, if at all, the sort of like, I suppose you could say topical subjects at the moment, and see how it could possibly help. All right, just very quickly, in terms of my background, professionally, I call myself a risk management consultant, and with that, I mean, I straddle really both domains, both business tech. My customers basically are people that I give advice to, so advice that's presented, like a report, dashboard, sort of thing. But where the tech part comes in is the advice is always based on models and data and analytics and so on and so forth. And then suppose about 20 years ago, I started to package a lot of that modeling, or a lot of that modeling, and try and get it into a product. And so software engineering is somewhat fairly newish to me, but sort of like dabble in and out. But principally, I would say, if you had to put me in a box, it's more data engineering, data science on the tech side of it, and then domain expertise is really on risk management. All right, so with that, I thought what would be good to talk about today would be on LLMs, which is it's been hot for them, ever since ChatGPT came about, and knowledge graphs. And I want to do an example of how we could use these two components to analyze code. So what I hope to go through today really is, just to start off with some knowledge graph basics, like what it looks like, for those who may not be familiar, some storage options, and then the very specific storage option I'm going to be using in the demo is Neo4j, which is a graph database. I'll look at some examples. And I probably don't want to spend too much time on knowledge graphs, because I think, it's probably, I, for one, find it a lot easier to understand some of these technologies when I start to work with an actual, example. So, with that, I'll be demoing an application that I'm actually working on at the moment. And it's Zotero. I'll go through what it does. That's on the business end. And when I did the abstract for this talk, I actually thought that would be good to sort of like show some of how I use knowledge graphs, or knowledge graph, to do the modeling, for the actual application in itself. But then I thought what would probably be more relevant for this group would be to actually apply it to the code base, and that, I suspect that the majority of folks in this group would be software engineers and, developers, up and anywhere along the stack, as opposed to being more, on the business domain side of things. And then that's where what I hope to go through would be, building a knowledge graph, from scratch. And I think this is the bulk of what I would be talking about. because it's something that I've been working on for, I've been working with knowledge graphs now for about, maybe about 2018, and then onto adding LLMs. And LLMs, my familiarity with LLMs is like most folks, since ChatGPT, but I was working with natural language processing, which is like sort of like the predecessor to LLMs. And that was really more for keywords and keyword search and that sort of thing. And then I'll probably hope to wrap it up with some key thoughts and some of my own views on how I see things, going to develop going forward. All right, so that's enough preamble. So I said, so what is a knowledge graph, right? Okay, so data.world, they're a sort of fairly largish knowledge graph tools vendor. They don't really sell, or well, they may, but they're probably more in the tools side of the knowledge graph world. Now, their definition, and this is copied verbatim from the website. They define it as knowledge graphs are a way of organizing and representing information in a machine-readable format. A knowledge graph represents a collection of real-world concepts displayed as nodes and relationships displayed as edges in the form of a graph used to link and integrate data coming from diverse sources. Now that's a hell of a lot of words, to sort of describe something. So I'll just give it to you in my own words. To me, it's just a way of representing knowledge. Knowledge would be something that answers questions within context. It has to be machine readable. Otherwise, it's just like a text report. It's accurate, and meaning that we can trace where that answer came from, and it's easily updatable. So, when you've got these four, so easily updatable, meaning that when you've got new learning or knowledge, you can easily add that to the graph, and then that really is part and parcel of how it works. So if you've got something like any of those four components in whatever you're using, in effect, it is a knowledge graph. Now, the reason why I say knowledge graph is because when you talk about storing a knowledge graph, and this is where it'll get quite confusing to folks who haven't really been in this space, working with the concept of a knowledge graph, is because there's actually many ways to store a knowledge graph. Okay, so there's graph databases like Neo4j, Janus. Janus is a big open source graph database. There's Tiger Graph, which is a couple of ex-Google guys started that, and then there's the RDF triple store, right? So these are the two big sort of technologies that are competing in the knowledge graph space. So RDF triple stores. RDF triple stores basically came from the semantic web. And semantic web is like the best way to sort of think about it. It's like Wikidata. So Wikidata would be, and Wikidata is stored in BlazeGraph, which is an RDF triple store. So there, every piece of data is modeled as with subject, predicate, object. So every piece of data is always think of it as must have two nodes and a relationship. So that's why it's easily connected to every other piece of data. Whereas, like say, if you want to contrast that to a graph database, you would you could have like nodes which have got no connection whatsoever to any other node. it's entirely possible, but then it wouldn't really be very functional to have just a hanging node. But it could be just a node that is waiting for a connection. Now, you could also model a knowledge graph using traditional RDBMS. So think about when Facebook started, and the social networks, not just Facebook, a lot of the social networks, they were all on LAMP stacks and that sort of stuff. So you could entirely have it on a relational database, or store a knowledge graph in a relational database. I think where the technology kind of moved to RDF triple stores and graph databases is because once you start to do joins and path traversals and that sort of thing, it gets it gets a bit difficult, just from performance as well as join complexity. And of course, then you've got folks like Elasticsearch. They are also playing in the graph space. So that's one distinction I would like to highlight. So it really doesn't depend. When you talk knowledge graphs, I would just focus on those four. At least from a practitioner's point of view, focus on those 4 points. So with that, I thought what would be good is to look at some actual examples of a knowledge graph before I get into the real thing, just to get folks a little bit familiar with what it actually looks like, and the types of questions you could ask of a knowledge graph. And because for me, what I've been using Neo4j for a couple of years. These examples are all from Neo4j, but don't let that distract from the fact that you could actually have a knowledge graph in Elasticsearch and whatnot. In fact, when I first was looking at evaluating like how which technology should I go for, I was actually looking at Elasticsearch versus a graph database, and I went down Neo4j purely because as a big vendor, they had a lot of resources, and they have their desktop graph database, which is a fully fledged product of comparable to their commercial offering, and that's available for free. Whereas a lot of the vendors for Elasticsearch, their free tiers were fairly limited. And then once I got started with Neo4j, I never really found a reason to move off it. So anyway, with that, the 2 examples I want to very quickly show are of, I can come from Neo4j. This is in their sandbox environment. And the first one is they've taken data from Stack Overflow API. They've modeled it into a graph database, and then we're going to look at like some questions that you could ask from a graph database. And I suppose the questions that I'm looking at is like, okay, why would a graph database be the best storage option, if I wanted answers to these types of questions? So let me just start. Okay, we've connected to this, so you can see that it uses the Bolt protocol, and it's that. Okay, first question that I want to look at is just to see what the schema looks like, and there we go. Let me just tidy it up a bit and see. Okay, so in this graph database that comes from Neo4j, and they actually in the documentation to this example, they've actually sort of shown how they got from the Stack Exchange API, queried the REST API, and gone all the way through. And here, in a typical graph database, you're going to see things like nodes. Like here, there's a user node, they've got a comment, they've got an answer node, question, tag. So these are nodes, and connecting these nodes are relationships or edges. Okay, so and the relationships and edges have got labels as well. So that's the schema. Now there's the it's just a schema. There's of course data points underlying each of these nodes and edges. Okay, so what's the first question? That I think. So the first question that I thought would be interesting is like, how are tags related to other tags? So as we know, as we get onto Stack Overflow, we see like a lot of these questions. I mean, they'll all be tagged, and so on and so forth. So it would be interesting to see which pairs of tags occur the most. If now one could look at this just contrasting with the relational database. You could say, okay, well, this could be just tables and joins or columns and foreign keys, and you're right, this is just a visualization. But when we look at, like, if we were to model this in a relational database, when we ask the question, how are tags related to other tags, we're actually going to be talking about, given the schema, right? Look at tag, question, these are paired. We're going to actually do a Cartesian join between each, to go tag to tag. You have to go through the question, come back to the tag, and so you're looking at like a real self-join loop. So this is when you've got a question like, how are tags related to other tags, and then you find yourself having to do these self-joins, especially when you don't know how many self-joins you're going to do, then you really are talking about something that is probably best modeled as a graph. So this code here is going to query the database. I'll show you now. So the first chunk of code is just Python sending the query to Neo4j, the sandbox environment. And here you can see how simple the syntax is for querying a graph database. This syntax is Cypher, which was started by Neo4j, but then what happened was, as more graph database vendors started to come onto the market, Neo4j opened it up, and so now most of these graph database, other graph database vendors, most of these other database vendors, they use Open Cypher. So this flavor of Cypher is Neo4j, but this very basic syntax, you can take it and use it on any other graph database. So it's fairly simple, right? So what we're saying here is.
Quick question: what was it? T1.name less than T2.name mean?
Okay, that one is saying that we don't want, like the two tags to be the same. The tag, when I'm looking at tag pairs, I want different, like Neo4j doesn't really tell me what I want. I want Neo4j and something else, or thing. As you can see, what I'm doing here is saying, like, look, I know Neo4j is going to come a lot, but I want a result a little bit more interesting than anything that, just to exclude that. So it's saying match node, and tagged is the relationship. I don't really care which other intermediate node that it has to go through. And then tagged again, because and we know from the schema, right? There's only one intermediate node, which is the question node. So to connect tag to tag, it's just this one line and you know, and I've got like how are tags related to other tags, and so I've got around that join, you know, that self join nightmare that you know, typically run into. And again, you know, I'm saying this like saying if, especially when you don't know how many self joins you need to do to get the complete result. Now you could say, oh well, you know, that's a modeling issue, but anyway, yeah, I mean, you could make any storage technology, you know, answer the question that you want answered. So let me just run this and see. So tag one, yeah, and here we go. Answer to the question: how are tags related to other tags? We've got Cipher Neo4j epoch, Cipher graph databases, 79, Cipher graph, Cipher. Now you can tell that because this was curated and extracted by Neo4j, it's all got their content, but you kind of, you know, get the picture that we do have that answer. So again, just reiterating the point, you know, whenever an answer requires multiple self joins, you know, it is going to be very tricky to do it in the RDMS thing. I mean, it can be done. People have been doing it for decades, but it's probably going to be worthwhile to look at whether it should be better modeled in a graph database. And the example that I am going to show is actually is how you could very quite easily go from an RDMS and port that schema into a graph data into Neo4j to highlight or to answer, you know, some questions that would be pretty tricky or more difficult to answer for an RDMS.
George, just a couple of questions before we move on. So Andrew's just checking that these tags are Stack Overflow tags, right? That
Yep.
we're talking about here. And also, so from the results, right? So this is when you had a question that was tagged with both tags. That was the frequency. Is that right?
Yes.
So that last one, right? So there was.
No. Okay. Yeah, because what this query is saying is tag. It doesn't have to be in the same question. Otherwise, I would have put a condition in here. So this is saying tag versus tag. So it's basically saying which tags occur the most together.
So they're together on any question.
Okay, actually, yeah. I think James, you're right. You know, when you phrase the question that way, it has to be in the same question.
So yeah, you're finding the relationship between the tags, basically, which things come together because they're together on the same question.
On the same question, yeah.
Sounds good. Thank you.
Okay. Are we good to move to the next example, or any questions?
That's all for now. Francis just saying that he'd imagine to do it in a relational database, you'd end up with lots of messy, ugly temp tables and tricky stuff.
Yeah, that's the thing. The second example that Neo4j have got in their sandbox environment, and I thought this one brings it a little bit closer to the demo. Would be, you know, dependency root cause analysis for IT networks. So this one, they didn't really show where they got the data to populate the graph database for. I mean, you know, for I know, you know, could be dummy data, but I'm just gonna same thing here in the code. You know, we're connecting up to the sandbox environment for this particular example. Here's a little bit of Python to send Cipher to the Neo4j. And what I'm going to do is just very quickly just run it and have a look at it visually, the schema. Let me just tidy this up. Okay, So let's blow it up. So what we can see here is I'll just bring it to this part of the graph database. So blow it up a little bit. Okay, so we got data center, egress. These are all nodes, and you can see that this is a modeling of the entire IT infrastructure. Now, this model that they're showing as an example is something that I actually saw in a Neo4j India Nodes seminar by Commonwealth Bank, and they've actually, when they were migrating their infrastructure to the cloud, they actually modeled, they started with one server and, started to build out the entire connection, because for them, they had so many servers that were just like idle and sitting there and just didn't know what was connecting to what. And so stack by stack, or rather server by server, initially, until a pattern started to form by ingesting data from logs, from server logs, and they built up their instruction, which gave them the confidence to plan the migration to from prem to cloud, on-prem to cloud. So that's what the schema in this sandbox looks like. So let's look at a question, because again, this modeling of a graph database really, and I'm saying this from a practitioner's point of view, you must have a question that needs to be answered. Otherwise, it's like, what's a node? What should be a node? What should be a property of a node? These types of questions are going to be pretty tricky. So always starting with a question, and then you'd kind of know, okay, this is how you'd want to model the graph. So question, what are the IP addresses of interfaces routed through the data center in Iceland? This is, of course, as an example, I mean, I did query the database beforehand, so I do know there is a data center in this data set that's in Iceland. So let's just look at the query. Again, identify the IP addresses for the data center in Iceland. This goes match data center location. So location is a property of the data center node. Star says, I don't care what the relationship is, but get me to the interface node and return the IP addresses. I'll just very quickly go back up to the diagram, and from here we can see the data center has to connect to the interface. It can go through the egress, it could go through the rack, router, so on and so forth. What we're saying in the query is really, look, I don't know what's in between these two nodes. Just connect that guy to that guy and just give me the 10. And so let's just run this and see what we can come back with. And here we go. Answer the question, what IP address do routers in the Iceland data center have? First 10 results only, and that's right. So that's where, when you've got questions that I suppose what's interesting about this example is, like, I didn't need to know anything about the interconnecting nodes, as long as I knew, my starting node, my ending node, and just use Cypher to query and say, just tell me, what were the connections, or give me the data when these two nodes are connected. So that definitely simplifies, the knowledge that you need to have about the data. Okay, so just quickly, let me render the markdown. So key points: representing knowledge in the graph database. Answers to questions represented by nodes, relationships, and their properties. it's the relationship that gives context to nodes. And here you'd say like, so in a relation database world, you'd have a foreign key, but between two columns in two tables. But in a graph database, two nodes, if you want to think of it in those terms, can have multiple relationships. And it's those relationships that give context between the two nodes or two entities, right? So if you want to think like John and Mary being two people from two data points from the people nodes. It could be one relationship label could be a sibling. Another one could be employee. So yeah, it's two identical two nodes, but the context given by the relationships. So that and these nodes really can hold anything. We can have tabular data. We can have in terms of data types. It could be blobs, could be text, keywords, so on and so forth. And I suppose the other thing that was mentioned about why graph databases are pretty good for these types of problems is because they're not schemaless, as you saw. I was throwing up the schema, but they're what I call schema flexible. I mean, you could pretty much swap a property, that's part of a node into you felt if it was better model as a node, then it would be good to have it as a node, and it's just a simple one-line thing in Cypher to run that query and pull out the properties and turn them into their own nodes with a relationship back to their source nodes. So that's the thing. Yeah, so I don't know, James, if anybody had any questions just on that overview of graph databases. Hello?
It doesn't look like it. So.
Sorry, my bad. Yeah, just Neo4j on Azure. Looks like Francis found Neo4j offered on Azure.
Yeah. They're definitely they've got their cloud offerings, and you could run it. I mean this desktop version is really for folks like me who are just like building and playing around with the graph database. But they actually they also do have a cloud offering which has got a free tier, and their thing is on Aura. We call it Neo4j Aura. Is their branding for their cloud offering, and they have it on all the platforms. All right, so very quickly, just going on to as I mentioned earlier, I mean I've been using Neo4j for my own purposes, and one when I started down this path of evaluating which storage option I should use, and I actually had a search problem, and that search problem was coming from Zotero. Now, I'll just at this point just want to give you I need to get out of this presentation and I'll show you what Zotero actually looks like as an application. It's a desktop application, right? There is Zotero Cloud as well, and you basically sync your content. So it's a bibliographic tool which is very big in the academic and scientific community. And what's really it's been around for decades, basically. What's really good about Zotero is this, like, say for example, if I was to see, browsing the internet and I found something really cool, I can just drag and drop, and we have tools like this, these days. But you could drag and drop all sorts of content, and there, and then it'll plonk it on here, and in just drag and drop, it already very quickly extracts a lot of metadata. Whatever that's available that's coming from the URL, and then you can then start to tag your content. So here we say LLMs, and then I can say, let's lose an existing tag, natural language logic, so on and so forth. Now, all of this, and I've been using Zotero for years, and this is a new, fresh installation of Zotero on this machine of mine. When you've got like my previous installation had thousands of YouTube videos, PDFs, websites, and so forth, and tags. I mean, like, try to search for something. I mean, like, at the moment now, I mean, the search issue for Zotero. Here's the thing: search, right? Title. You can search through all the structured fields, any field, and let's say, let's type in, I don't know, and let's say search, right? So it's gone through the tags, and it's picked up LLMs, the tags, so on and so forth. But say, when your tags then start to go into the hundreds, right, you're going to have a problem. Because what I would like to do also is to have create from my tags, create a taxonomy and an ontology and those sorts of things for more effective search, because I just don't have control over the hierarchical nature of these tags. I want to create a hierarchical nature on these tags, and so that's going to happen. That's going to be a bit of a problem. So anyway, so I like this. I like it's so easy to use. So I really want to keep this an application. But what I want to do was, if I could get the tags and the documents out from the back end and create my own search, semantic search engine, and get the result from that search, if you want to call it a plugin, or my own bespoke search application, customized to how I want to rank the results, how I want to do that. That would be the great add-on to this tool. So that's how I got started, into looking at search technology and evaluating how am I going to actually do this. So let me just get back onto. Okay, so here we go. The saying is meta content, some of these things I just mentioned. I just want to keep Zotero at the front end, and then extract what I need, and then build my own such as a side application. So what would be my user flow? I'm just going to throw. So here we go. I'm going to get a search result. So that when I say search result here, I'm talking about a Google. On the website, I'm going to, Google's going to show me something that I want to keep. As a PDF, it could be YouTube. I want to drag and drop, go into Zotero, right? And then because it's just sitting there, I just want to tag it very, very quickly. What I want to do is, from the back end, I want to go and pick up Zotero, hack into the database, pick up what I need, throw it into, and create a knowledge graph out of the data, and then do my search on top of that data in from the search engine from Neo4j, and then I'll leave basically the content still sitting within Zotero. So it's almost, if you want to say, a plugin, but not a plugin on top of Zotero, but basically a search plugin, but using it's an application built on top of Neo4j. So that was really something that I've been working on. Now, rather than sort of like in context for this group, I thought, yeah, that whole exercise is really dealing with a lot of text and keywords or tags, keywords, sort of building page rank, your own page rank and so on and so forth, and then really dealing with more language, based thinking, and a lot of that work is sort of dealing with document processing, right? So it's chunking and entity extractions and so on and so forth. What I thought would be more interesting is still staying within the Zotero Neo4j world is what if, because even for me to build that sort of, right, I still need to understand how Zotero is put together, right? Because I don't know anything. I mean, I'm only just using the application. I'm the application user. What does it look like? What's sitting in the back end? So all of that sort of stuff. So Zotero as a desktop application, it's using SQLite as its backend, and once you find that where that file sits in your in your file system, you can then query that. And I'm just okay. You can see I'm connected to Zotero Lite, and that one. I'll just show. Let me just run through that code. So you can see I'm connecting to the SQLite database that sits on my C drive. So it's connecting fine. And let me have a look at the database. Okay. Want to extract the schema. It sits, the schema for SQLite is in this SQLite master table. And let's just have a look at what that is doing. Okay. So I know in this little chunk of code, I've got some Neo4j logons here, but it's not. I should have really taken that out, because all I'm doing here is just using the pragma is the stored procedure to query tables and get table info from any SQLite table, and that will give you like all the column information, so on and so forth. And like SQLite master is where the schema information is stored, and just running the SQL. And so what we've got here is that in this Zotero application, there's 61 tables, 83 indices, 12 trigger objects. So that's really what the data, the database layer is all about. Now, yes, okay. So far, we're still in the RDBMS world, relational world with SQLite. Now, 61 tables. We've got all the IDEs. I mean, we have tools, right? To look at a database schema. So the question then becomes, right, why then would we need to use a graph database? Why you've already got it. You've already got a tool to visualize what the tables and the foreign keys look, visually at least look like. But here's the problem, right? We want to ask a question like how are any two, a typical question like how are two columns connected, or what are the connections between two tables? Yeah, 62 tables, lots of entries. Why? I think what I want to do now is like say it's still quite small. Let me just step out of this, and I'll just show you. Okay, in let's see. Let's see what flow diagram. Let me load this. Okay, so visually, let me just, for the time being, just try to show it. Okay, so it's only 61 tables really, because the 62nd table was the schema table. So you could see now, to find out how any two tables are connected, and you know, I'm sure we've all done this before. It's like to actually follow, you know, follow the foreign keys and say, okay, that guy. If I wanted to find out how that guy is connected to that guy, I just need to follow. Okay, so but it's okay, you know, it's only what do you call this? You know, it's something that you could do visually. But here's the problem, right? If you okay, yeah.
Hang on, George, one sec. Yeah, please comment if you're still getting the video and the sound. I just got an odd message from StreamYard. I want to check we're still live there.
Yeah.
Hang on one sec. I think StreamYard has ended the stream on us, which is weird. So I'll just restart it. Let's see. Francis, have you got Twitch up by any chance?
Yeah, I can see it. I can see some scrolling happening.
Yeah, we're still getting it coming through Twitch.
Okay.
Still coming through?
Is your audio working?
Yeah, I mean, I can hear you guys.
Okay. Yeah, funny enough, it's a good thing I'm in Korea this month and not say February, because I think that's preaching Korea is going to be going out of business. So
So it's dropped off the Twitch, is it?
I think Twitch is like losing loads of money, right? And who bought it? Is it Facebook that bought it? No, Amazon bought it.
Amazon.
Yeah, and they don't know what to do with it. They haven't been able to monetize it. Yeah.
No, I think they stopped running it as when Emmett Shear, one of the founder who left, he was the last, you know, like founder CEO, left. They pulled it into Amazon Prime Video, so it's kind of got merged. Because prior to that, it was still as an independent unit within Amazon. So it's just got absorbed into the video of Prime. Boy, we were really running out of time.
Yes, yeah. I think we're kind of running out of time, so maybe if you could just summarize.
Yeah. Oh, you let me know when we're good to go.
I mean, the fact that it's still streaming, I think we are good to go. I'm not sure.
Well,
Yeah, because I can see it. I can see it on Twitch. I can hear our conversation on Twitch. So I would say just keep going.
just keep going. Okay. So anyway, like I said, so it's coming back to this. Why I would want to throw a what's already in a relation database schema into a graph database. It's like I said again, always focus on the question. How are sorry. Yeah, how are two columns connected? So let me just run this. How are any two columns connected? So what I did was I just not mapped, but with code, just transferred the schema from SQLite into Neo4j, and that is just like pure code. I'm not doing any kind of human mapping or anything like that. It's just using SQL functions, throwing them into there. There's a little bit of cipher that I need to do to model what's coming through from the RMS schema, and that's when I will now just run this and say, now this is okay, so that's coming from SQLite. Now this is what's in Neo4j after I have transferred the schema across. Okay, so what I've got here is tables, a table node, a column node. This chunk here, I don't know. It's something in my Neo4j database that I can't seem to get rid of. But just for the moment, just ignore that chunk. We've got the relationship between the table node and a column node. There's this. I've read the foreign key info from SQLite, and it's saying that there's a parent table and a child table, and they all connected via columns, and that's this particular type of modeling is to answer that question. If I want to know how two tables are connected, then this is the model that I would be interested in working with. So, for an example, now that I've transferred the schema from the relation database into the graph, this is what it looks like. Okay, so now let's say now that the transfer has happened, let's say we want to answer the question: what's the relationship between item annotation? What's the relationship between the item annotations table and the libraries table, for example? What I do here is I go to Neo4j, everything is there. I would say match, item annotations. It has to go through, a parent-child alternate between parent-child relationship through a column control, and end up with the library. So I don't know end up with in the libraries table. So I don't need to know anything about how many tables it needs to and columns it needs to go through. The only caveat being that it has to be a parent-child alternate in alternate, and that's what this code does. In alternate. So I don't know. It could be. It could be any two tables. I could have picked any two tables here, and I'm just destroying the table, and I'm just going to run it now just to show you the results. Okay. And okay, so item annotations. it has an item ID column, right? It goes, which gets it from item attachments table, which then that item attachments has got a child parent relationship to the items table, and it goes through the library ID to the libraries table. So just that if you wanted to see how two tables are connected and how they're connected, this is it. I just like having transferred the RDBMS schema into a graph database schema with knowledge that that's the type of question that I want to answer. I've got a very, very clear path mapped out for me. So I would know. So you could say, well, for this particular application, it's only like 61 tables, right? It's not that complicated. But I think about earlier in this year, I was on a gig at NBN, and we were placing the ERP system from Oracle to SAP for HANA, and Oracle EBS, that's got 24,000 tables. And my job was to, they wanted to know, how, what were the connections between these tables? Yeah, fine, we've got a schema, but can you imagine trying to do this, brick by brick, table by table, and then map that across to SAP? It was just like a nightmare. So the idea that I was trying to champion there is, no, we should just pick up the schema from Oracle, throw it into a graph database model, and then analyze. Okay, if I want to know from this table to this table, what is the path? What is the connection? So in this smaller example, you can see how it is. Now, I'm also very conscious we're already going past, and we've still got quite a ways to go. So I suppose what I wanted to do, the key point here is this is where a knowledge graph or a graph database, I use those terms interchangeably, but a knowledge graph is basically something that can answer some particular types of questions. It really comes into its own. And you can at the moment now there's no LLMs or anything involved in this piece of the puzzle. Now we've talked about I've talked about the database side of it. I've got a whole section here on dealing with the application stack, right? So I won't go through all of that. Suffice to say that this type of modeling, right, of the entire application, entire code base of an application that I'm completely unfamiliar with. I've just gone through the database. I could go through the code and map, go up with the thing, like say which application code speaks to the database, what are the functions, and have that all in a graph database. So you could see the entire supply chain, and with the queries, I could just pick out a function and then understand where and how everything sits. Now, what I think I might do is I'm just going to very quickly, just in the interest of time, just start running. Okay, so so in the end, right, what I want, this is just a diagram of what I want the graph database model to look like. You saw this part of it that I ran earlier, the columns connected to the table, and on the application side, there's a schema JSON that talks to the database, and each code, has got functions that talk to this schema, and this is the individual files, and this is where the repo subfolders are. All of this, I've actually got actual code that, so I won't run through it. And then because the documentation of the application code is lacking, I've got this little hanging node here, right? Where what I want to do is, as I'm ingesting, and all of this is code, right? I'm just running code, traversing the entire repo, and throwing it all into Neo4j. Of course, there's there's a schema in mind, and this is the schema design that I've got here. But at the same time, I am also, because there's no documentation, how I'm doing it, when it comes to the actual various APIs and whatnot, is I'm actually going through the abstract syntax tree and pulling out, what are the function names, what are the parameter names, all of that, and that's how I'm extracting. So I'm actually using the syntax tree to extract, the information I need from the code base and from each file, and then putting it into Neo4j. But at the same time, as I'm doing that, I'm sending that code to well, I'm using OpenAI, and I'm saying, okay, here's a huge chunk of code. Can you tell me what it does? Okay, so that is what I am doing here. Let me just run this, and I'm just going to very quickly rate nodes resolution. Okay, so earlier you saw this is Neo4j. And I've done this, and we've got the column. We saw this little piece of the schema earlier, and here I've just taken one file, which is one file from the repo. It's called API.json, and I've extracted the function names. It's got the file information here. It's got the repo sort of thing, and then I've got this little empty node at the moment because I haven't sent anything off yet to OpenAI, and to generate the documentation for it. So what I do know is that right up until all of this all these nodes, all these relationships, all these things, everything there is no human intervention, in the sense of like everything is reading off either from database, the schema, and all the code is coming off the actual code base itself and the abstract syntax tree. So that's how there's no hallucination, conjecture, reading of documentation or anything like that. That is purely what static code analysis tools do. They just read code and pass it and generate that. I'm using that same methodology and throwing it into a graph database model to see how do I go from code to the database. All right. So again, right, what I want to do is, you saw that hanging node. All of this stuff is quite irrelevant in the interest of time. Okay, this one is fine. It's fine. I wanted to talk about, so where do LLMs fit into this whole thing? Because at the moment now it's just code talking to code, right? I mean, so the first thing I want to show is like getting ChatGPT to explain code blocks in natural language. So what I'm doing here, what this chunk of code is going to do is going to send that API.json to ChatGPT. I'm using the API. I'm going to prompt it with specific instructions to get markdown tags, extract the text property, and create a relationship, and then populate that empty node that I created, right? And link that node now that will have the result from ChatGPT back to the main schema. Okay, so let's just run that. Okay, so it's done. It's thrown it into JSON. Now, what I want to do is, like, JSON's of course not that friendly. I'm just going to quickly, because remember, it's come back from the result from ChatGPT, it's come down with all the markdown tags, and all I'm doing here is I'm saving it on my file system as a markdown document. Let me just show you what that looks like. Exit presentation node. Let's see. That's that one there. And this is exactly what ChatGPT from that. Okay, I'll just show you what the original API the JavaScript file looks like. So I sent this to ChatGPT, and ChatGPT came back with this. So it's looked at it, and it's come back with, all of these things. Okay, it's got 2 objects, all of that stuff in there. And so if someone wants to see what API.js did, that's what it did. Well, this is ChatGPT's explanation of what it does. So let me go back and here's to somebody by me. Get back to the notebook. Okay, so here we are. Now this part is seen. Okay, now what I need to do is, okay, yeah, here we are. So now this part of the code, I'm connecting that node, that thing, I created a thing that connected the node back to the main code base. So let me just do it that way, and here we go. So previously, this is that little bug that's in my Neo4j, but that ChatGPT document, code.gpt, has now connected. I've connected back to the API.js file. This is the repo subfolder has a location in the repo, and what I didn't show earlier was when I passed the API.js through, and I extracted all the functions. There are actually 5 functions, right? And you'll see this in a minute, which is what ChatGPT concurs with. 5 functions that came back from the past, and then so we've got that. Those 5 functions all data points in function data points, and then we've got that all connected. So I mention 5 because I'm just going to show you a result now. Why the next part is, so we sent API.js to ChatGPT to get an explanation of what the code is. It's all now tagged on to the graph database model. Now, if you didn't, from now at this point, because I know Cypher, I think I can, and of course, it's thrown the markdown version of what ChatGPT thinks is an explanation of the code base or the code file. It will, I can read all of that, and then I can query this entire schema using Cypher. Now, what if I wanted to chat to this code base, because I didn't know Cypher and I wanted to ask some natural language questions? Then this is where this whole concept of GraphRag comes in. So basically, what I want.
George, we're going to need to wrap up in a few minutes.
Yeah. Okay. So basically, okay, I'll just wrap it up now without showing stuff. Basically, with GraphRag, all we're doing is we are basically going to ask questions in natural language, and with GraphRag is nothing more than prompting ChatGPT with the schema, which is all the schema on X, with a very specific instruction, use a schema, come up with Cypher, with a Cypher query that will extract as per the question that is being asked, and base your results on that. Base your response on that prompt. So that is that's what GraphRag is all about. That's why they keep on saying, oh, it's grounding the LLM. Because I do have an example, I won't run it, but I do have an example where if you didn't provide those very specific instructions to ChatGPT, ChatGPT will either one come up and say, I don't know the answer, or I need more information, or it'll make stuff up. So GraphRag is basically here where is saying when the graph part of it is like, from the question, translate that to Cypher and query the Neo4j for the extract, and then put that in the prompt, send that to ChatGPT, do your thing, come back with a plain with a natural language explanation or to the natural language explanation or answer to the question. So that's kind of where the LLM part piece comes in, is like, oh, I've actually got some results here. So so this part of the code is when I don't prompt it, which functions mention a specific table schema, it comes back and say, I don't know the answer. But then when I do a few shot learning prompts, and I say few shot, this is all part of the code, it will come back and say, which functions, okay, let's say the question was, which functions refer to a specific table schema, specifically the DB schema JSON? Please return your answer in natural language. That was my question that I typed into the chat. It came back, the functions pass params, get results from params, get library, blah, blah, blah. All of that came back. And in the earlier thing, which I didn't show, these are all the 5 functions that were in API.js. So because the response from the response or the instruction to ChatGPT to base its answers from a Neo4j extract that made it into the prompt, that's what it did. So that was it. Now, just a final thing, I've also tried to do what's called a vector-based search. And that one, what I did in this question was, how many functions are mentioned in the documentation? Now, this documentation was me throwing API.js to ChatGPT, asking it to come up with some documentation. In this query, what I did ask in the prompt was, base your answers on the documentation, which we know came from ChatGPT, and say and the question was, how many functions are mentioned in the documentation? And it says there are 5 functions mentioned in the documentation, which is exactly the same number that came from the abstract syntax tree. So it's kind of like the LLMs in this whole piece only is where you've got a human in the loop, and you need to interact with the human and get human input or understanding or querying of the graph database. So, but if you know code, I mean, for me personally, I didn't see much need to create a chatbot on top of Neo4j, because I'm the sole user for my personal application. So then, because I my Cypher is very basic, but just basic Cypher, I could get all the search results that I needed. But if somebody else wanted to use it, I'd just put a chatbot on top of it and use GraphRag, and yeah. So anyway, so that's kind of where I want to wrap it up. I think just saying, if you've got a problem, it's got complex relationships, multiple joins. So just have a look at a graph as a way to model the problem. Second tip is always have very specific questions, because that helps in the modeling. You have to have the schema flexible, and LLMs where LLMs fit depends on where the human in the loop is going to consume whatever you're doing or building. So thanks, guys. Sorry, it's really gone quite late, but yeah, that's what I wanted to hopefully share and be.
Thank you very much, George. And it's great to have someone from more of a data side as well, because you take such a different perspective to the way you look at the code and the way you look at the data and stuff. Whereas, developers are very code centric, you're so much more data centric. So it's a great perspective to have a look at these things and also see you using it through the notebooks, which is a really neat way to do it too.
Well, thank you.
Do we have any questions for George? Anyone want to put anything in the chat? I know it's a bit late, but if you've got any last questions. We got to thank you for new and useful stuff. Thanks, George.
No worries. And anybody wants to reach out or just talk a bit more, I'm more than happy to the George at mcmc-capital.com. It's probably my email and the easiest way to get in touch. Or you can find me on LinkedIn, George Jarrett.
Sounds good. All right. Because it's getting a bit late, I might just go to the questions for the audience at this point. So stand by. So first question, this one's pretty easy. Come on, you should be able to get this. So for the JetBrains license, so what graph database did George use for all his examples? There you go. Here we go. So I think the winner here is KYSDDR Kizdr. Sorry if I've mispronounced your handle there. So I don't think I've given you a license before. So send me a message on Meetup with your email address, and I'll send you through the license. K's, it sounds better. All right, that sounds good. And the second question. All right. So this one is so from George's original slides, and I think also in the wrap up. That's a bit of a nice hint. So what do you need to design your graph schema? What do you base it around? This one's a bit more of a difficult question. Francis doesn't need a license, as you can tell by his answer. And George's giving you a bit of a hint. Whoever gets this one gets their license, even if George highlighted it for you on the middle of the screen. What have we got? No one's answering.
I think we've given away too many licenses. I think half a sitting has one, right?
Everyone's scared off by having to give a talk if they get a license.
Yeah.
What was the question again?
My question is right, before you come to designing your schema, you need to have something to base it around. And George has kind of highlighted it, and at the beginning and the end, he's designing his schemas to do something in particular, right? It's not to store data particularly. It's to do the thing that he's highlighted in the screen, not to say it myself. To interview questions. I think Stephen's got it. Is it knowledge graph to answer specific questions, right? So what I was fishing for, and I know it's a bit of a harder question despite it being up on the screen, is Stephen's answer, right? So I think George was saying that he designed his graph to answer specific questions every time, right? So, if you're making a web app, you might be doing it to store databases, but his knowledge graphs were all because he had a question that he wanted to answer. And that's why he designed his schemas that particular ways. Is that right, George?
It is. Just very quickly on that. So you start off by, just to get the knowledge graph up and running, you start off by answering specific questions, but then very quickly the ontology comes is another big word, but the more general concepts come into play, and then that so it's not just very, every graph database looks different, but to kick things off, just start off with a very specific question in then design, and then you kind of you can change the schema as more questions and more, the thing becomes more general purpose. But yes, you're right, James. It's start off with specific questions. Get started.
That sounds good. All right. Well, thank you again, George, for sharing the talk and preparing so much material as well to share with us. So
no, not at all. I'll just need to be more conscious of time in future.
Yeah. So next month we've got Stephen's going to be talking to us about coding complexity and some other interesting things. So please check the meetup site. Let me give you a better taster for what he's got to say. So it's on technical debt. So how much can you choose to pay, and how much can be chosen for you? So Stephen's also another alt.net member. So we're very lucky to have our members stepping up to present for the end of the year. And in fact, we've got a talk for January planned as well. So we'll put that up on the meetup site soon too. Another AI coding related one. All right. So thank you, everyone. I can't actually end the stream because StreamYard, and sorry for the technical difficulties, StreamYard kind of had a hiccup 2/3 the way through. So you just have to close your browser and we'll just have to leave. And I'll send George and Francis, I'll send you a link afterwards via email. Because it's unfortunately the technical debt in StreamYard, as Francis said, has been this year.
You can't blame me.
Good night.
All right, good night, everyone. All right, ciao.
Yeah.
Bye.
Yeah.
Okay, thanks, James. Thanks, Francis. Thanks, guys. See you around. Bye.